Today we're going to talk about some relationships that exist when special types of lines or segments interact with triangles. So the first one is an angle bisector, something we talked about towards the beginning of the year. An angle bisector is a segment or a line that intersects an angle and cuts it in half, which means it makes two smaller, congruent, or equal angles. So if you look at this picture, angle C is being bisected by this segment CD. I know that because I've shown you these two angles are congruent. And so it takes the three sides that we had and it cuts one of them into two pieces. And then we have the other two sides still remaining intact. But we have four segments now. Two original sides and one side that's broken into two smaller segments. And so if we look at their lengths, we have this relationship that exists. We create a proportion. A proportion is two fractions that are equal to each other. So if you look here, this side that I've labeled W, that's just a variable that's representing the length of that side. If I divide it by this side labeled Z, that fraction should be equal to X and Y, these two small pieces. Those two fractions should be equal. So if I know three of the lengths, then I can find the fourth length out using this relationship. It also works if I take W and X, set that equal to Z over Y. So either way would work. You could also flip all the fractions and they would work out the same. So X over W and Y over Z. So let's look at an example. Here I have one side that's question mark, the other side that's 30. One of my small pieces of the side that's broken up is 15. I need to find out what this piece is to use the relationship. So I'll just do 36 minus 15, and I'll find out that this piece is 21. So now I can set up the proportion. There's two ways. I could do 21 over question mark equals 15 over 30. And in this picture, if you look at that, those fractions kind of set themselves up. 15 is sort of right on top of 30, and if I wrote 21 in here, it'd be right on top of question mark. You could also write it as 21 over 15 and question mark over 30. So again, those fractions would set themselves up perfectly if you just sort of flip this picture 90 degrees to the right. Whichever way you set it up, if you cross multiply, which means I multiply the top over here by the bottom over here, the top on this side by the bottom on that side, I get 21 times 30 equals 15 times question mark. Simplify and solve. I'll find out that that side over here that's labeled with question mark is 42 long. So let's try another one. Here question mark is my whole side, so I got to do something a little bit unique. I'm going to take this piece and I'm going to call it X. So we're going to find X, and that's going to help us find question mark. So here's my two possible proportions. X over 7 equals 20 over 28, or X over 20 equals 7 over 28. I cross multiply, simplify, and I get X to be 5. That means this blue piece right here is 5, but I want to know this whole side, so I'm going to add 7 plus 5 to get 12. So I want you to pause here and try this one on your own. There's no tricky bit to this example, just a little bit straightforward using the proportions. So I like doing it this way. 48 is right on top of 30, 24 is right on top of question mark. That proportion sort of writes itself. You could have done it this way, 48 over 24, 30 over question mark. No matter which one you did, if you cross multiplied, you'd end up with the same thing. Simplify and find out, oops, sorry about that. You find out that that piece is 15. So a similar relationship exists if I have a triangle and then some segment or line that goes through the triangle and is parallel to one of the sides. So right now I have this line, this segment that intersects the triangle, and it's parallel to this side. So again, I have 4 pieces, but this time it's the 2 sides that are being intersected by this line creates 4 smaller pieces, and those pieces create this proportion, W over Z, X over Y. You could also do W over X and Z over Y. I like the first one because, you know, if you were to sort of rotate this just a little bit, W and Z, W is kind of right over Z, X is right over Y. Those fractions kind of write themselves. So let's try a couple. Here, nothing tricky. I have this line, or this segment is parallel to this side. That's what the red arrows show you. I can do 8 over 20 and 18 over question mark. Or I can do it this way. I'll cross multiply, simplify, and I'll find out that this piece is 45 long. Which should make sense. If you look at the picture, it's the longest piece out of those 4. We'll do another one. This time we had a little added layer. We need to know this part of the picture. So we can do 14 minus 4 and figure out that that part is 10 long. We can set up the proportion, kind of writes itself, question mark over 15, and then I can rotate that a little bit. It'd be 4 over 10. Or you can write it that way. Cross multiply, simplify 4 times 15, and we'll find out that question mark is 6. So go ahead and pause here. This is a little bit like one example we did with the angle bisectors. You might have to call something X first, find X to find question mark. So this was a little bit extra tricky. I need to know this piece. That is 24 minus 15, which is 9. Then I'm going to have to find this piece before I can find question mark. So there are the 2 possibilities for the proportions. I can cross multiply, simplify, and find this blue piece to be 15. Question mark is the whole side of the triangle, so I'll add 15 and 25 to find 40. Another possibility here would be to do the whole thing, question mark, over 25, and 24 over 15. So if you notice that or picked up on that, you'd be able to find your answer the same. So I've got 2 for you to try. Use the ones we did as examples. Make sure you submit your answers online using the Google form, and We'll practice and answer questions in class.